Welcome to another class on permutation and combination. And what is permutation? What is combination? Let's start like this. You have AB, you have BA. AB and BA is of two permutations, but they are the same combination. So combination is 1, but permutation is 2. Wow. The reason is because permutation deals with order, but combination does not deal with order. Now, what we mean is that if you check this A, B, and BA, the same letter present here as combination. Either you brought A first or B first. Since the order is not our concern for combination, that's why both are what are the same thing. So that's 1. But permutation, it means they are different. So that's the word permutation. Like A is coming first before B. So that's the word permutation. Now, another example is if you have ABC, ACB, BAC, BCA, CAB, CBA. Now if you check this one is 6 permutation. The permutation here is 6, but the combination here is 1. Why? Is that this one deals with the arrangement or the order is concerned here. But this one, it deals with selection and the order is not concerned. That's the difference between the two. If you check it very well, ABC, ACB, BAC, they have the same thing present in them. So that's it. The same elements, the same letter present in them. That's why it is one combination. But it is we have this one is different permutation because A starts first there, it also starts first there, but B is second there and C is second there. So if you have order like that, if you are considering the order, it is permutation. But if you are not considering the order, it is combination. Now we have the permutation to be n permutation. Our formula is n factorial over n minus r factorial. Therefore combination, n combination r is equals to n factorial over n minus r factorial r factorial. Now this is the formula for the combination. Now 1 factorial is equals to 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Even 5 factorial is 5 times 4 times 3 times 2 times 1. 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. So that's all about this. Now before we move to the question aspect, now we have what is known as, let's look at the differentiation between the permutation and the combination. Note, I told you the first thing is that permutation deals with order, but under combination there is no order. Don't consider the order. Number 2 is this. The permutation contains it deals with the arrangement, but the combination deals with selection. Number 3. If you are talking about the permutation and there is repetition of letters, then you use the formula n raised to power r. But if it is without repetition. Without repetition of letters, then you can use N permutation R. The same thing with combination. If it is with repetition, then we can use N plus R minus 1 combination R. Then, but this one, if it is without repetition, we have without repetition, and this will be N combination R. Now this is the difference between the permutation and the combination, or let me say the cases or the formula that we have between the two. Now let's take a look at questions. The first question says, in how many ways can 5 different books be arranged? In how many ways can 5 different books be arranged on a shelf? Now they already talked about the arrangement, and when you talk about the arrangement, that's permutation. So the 5 books, that's 5 books, 5 different books on a particular shelf. So because it's on a particular shelf, so the answer will be 5 permutation 5, because we can have it to be, if this is the shelf, can have A first, the second one, the third one, the fourth one, and the fifth one. So we can have A, B, C, D, and E. So that means the order is concerned here, because we can arrange the book A first before the second one. I can take book B first, then put book A to be second one. You understand? So the order is concerned here. So that's why it is 5 combination 5. And when you press 5 combination 5 on your calculator, 5 permutation 5. So because the order is concerned, so 5 permutation 5, we have it to be 120. So the answer is 120. So we have it to be 120 ways at which the book can be arranged. Number 2. How many 3 letters words can be formed using the letter from the word table. Now if you check this very well, this is it permutation or combination? It is still permutation, because the order is concerned here. Because you can have 3 letters from the word table. We can have TAB, we can have CLE, we can have TBA, we can have LEB. You understand all those things? Now, the reason why the order is concerned, and don't forget that this is a 3 letter, this is also 3 letters. Now, there are 3 letters, different 3 letters word, but don't forget, this one, the T start first here, but these are the same thing. Even I can have BAT, it's still 3 letters. So these 3 letters are different, but they contain the same numbers of words, of letters. They contain the same letters. That is, they contain the same letter, T, A, and B, T, A, and B, T, A, and B. But T start first, A second, but B second here. You understand? So that's why it is permutation. So the ways of forming 3 letters from this table will be permutation, because order is concerned. So the order is concerned. Assuming the order is not concerned here, these 3 now are the same thing. So it is one combination. This 3 is one combination. but we need permutation here. So that means the total number of letters in this table is 5, and that will be 5 permutation. The letters we want to form is 3 letters, so that's 5 permutation 3. Now if you press it 5 permutation 3, we have the answer to be 6 letters. That's 60. So we have 63 letters, 63 letter words can be formed using the word table. Now let's see another example. Now another example says if you have a committee of 5 members, a committee of 5 members is to be formed from a group of 10 people. Committee of 5 members is to form from a group of 10 people. In how many ways can this be done? In how many ways can this be done? Now, a committee of 5, these are people, not even alphabet. Let's see. Let's even talk about, they said a committee of 5 people is to be formed from 10 people. Let's even list 10 people. Can I have Blessing? Can I have David? Can I have John? We can have James. Can I have Gloria? Can I have Edith? Can I have Jack? Can I have Hope? Olive? Ella? A committee of 5 can be formed from what? From the group 10 here. Now many ways. This should be combination. That will be 10 combination 5. The reason why it is combination is because now, unlike this one that talks about the letter, I told you that C can come first, yeah, B will second. But if you want to do this one like that, like you have a committee of Blessing, David, Jude, John, James, and Gloria, and you still want to form another one like this one. No, in this one we have TAB. It's the same thing as TBA. So T is here, A is here, A is here, B is here, B is here. But this one now, the same thing. You still want to form, let's say Gloria, David, Jude, James, John, and you have Blessing. Now you can see that the same numbers of people that are here are the same numbers of people that are here. That is the same people that are here are the people that are here. These are people, not like alphabet that are here. If this is a committee, these same people that form this committee are these same people. So this one and this one are the same. So that's why we are using combination. Unlike this one, which is permutation, this is alphabet. So that's why it is permutation here. So that's the reason why we'll be using combination here. So because it is people. So sometimes, most especially if you are using committee people as an example, it's always deal with combination, because imagine a person belongs to this place. The person will still belong to the ones. It's still the same person, not like alphabet. So that's it. So order is not concerned here if it is combination. Now we have it to be 10 combination 5. And the answer is 252. So we have 252 ways at which the 5 members committee can be what? Can be formed from 10 people. The next question. The question says, in how many ways can the letter in the word question be arranged? Now if you want to do this, I would suggest you use the probability law. That is, check question. Question contain how many letters? 1, 2, 3, 4, 5, 6, 7, 8. We have it to be 8 letters. So now have it to be So numbers of ways at which this will be 8 factorial. Now check all over. You can see that we don't have any letters that repeat itself twice. Assume we have, but everything here appears once. So that will be 1 factorial multiplied by 1 factorial multiplied by 1 factorial etc. And 1 factorial is 1. So that's why we may not need this denominator. So the answer is just 8 factorial. And the answer here, we have 8 factorial here to be 40,320 ways at which the letters in the word questions can be what? Can be arranged. Now another question says, in how many ways can 6 people be arranged? In how many ways can 6 people be arranged in a line? In how many ways can 6 people be arranged in a line? The same thing. So this one will be 6 people. It is arrangement. So that's permutation 6. Yes, in a line. So 6 people, permutation 6. So that will be 6 permutation 6. Each person can govern, can be at a particular side. So that's 720 ways. We have 720 ways at which they can be what? They can be arranged. Another question says, how many 4-letter permutation? How many 4-letter permutation can be made? Can be made from the letter in snowflake. How many 4-letter permutation can be made from the word? From the letter snowflake. You can see that the thing is that if you check this snowflake, it has how many letters? We have S here. S appear only once, N appear only once, O appear only once, W appear only once, F appear only once, L appear only once, A, K, the same thing, they all appear only once. So since it is the arrangement, or let me say the forming of the words, how many they are even talking about the permutation. So that means you now have it to be, the total number here is 1 2 3 4 5 6 7 8 9. So we have 9 letters. So that will be 9 permutation. They said 4 letter. So that means it will be 9 permutation 4. So the answer here is 9 permutation 4. The answer is 3,024 words. 3,024 words. That is it. Next one is this. Another question says, how many ways can the word commerce how many ways can the word commerce be arranged? Now in how many ways? Now let's see. Commerce as it is, it entails 1 2 3 4 5 6 7 8. So we have 8 letters from the word commerce. Now since we have 8 letters from the word commerce, then we can say, let's use the methods that we use initially, like the probability method in this one. So if we want to use this one, if we want to solve for this commas now, I'll now say, now what are those alphabets that appears? C appears twice. So we have 2 for the C. So that will be 2 factorial. We have M as well. M appeared twice. That's 2 factorial as well. We have E as well, appeared twice. We have it to be 2 factorial. Other appears 1. So if you are putting 1 factorial is still 1. So it does not have any effect. So that's why. So you can still put it, but it does not have any effect. So your answer here will now be 8 factorial over 2. The total number factorial over each of the numbers here. That's 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So the answer here, if you press it, so we have 8 factorial over 2 factorial multiplied by 2 factorial. Sorry, let's press again. We have 8 factorial over 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So the answer is 5040. So we have 5040 ways. So let's proceed. Next one. Now, for the next one, the question says, in how many ways can the letter in mathematics be arranged? In how many ways can the word mathematics be arranged? So I'll still use the same method. Mathematics entails 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11. So that will be 11 factorial. Total number. Then let's see the numbers that appear. We have M appear twice, 2 factorial. We have A appear twice, that's 2 factorial as well. T also appeared twice, that's 2 factorial. H appear once, E appear once. So we have I appear once, C appear once, and S appear once. So the answer will now be 11 factorial over each of these, which is 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So let's press. So we have 11 over 2 factorial, sorry, we have 11 factorial over 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So the answer is 4989600. So that's it. Now the next one is the question says, how many ways can the word mathematics be arranged in which vowels occur together? Now the mathematics, this one will now be different from the previous one. Now they said for mathematics, so they said the vowels occur together. Now let's bring out all the vowels here. You observe that the vowels here, we have A, we have E, we have A, we have I. These are the vowels. And the remaining values will be M, we have T, we have H, we've already written E, we have M again, we have T, we've written I, we have C, we have S. Now these are what? These are the consonants when we remove the word, the vowels. Now this is how you are going to do it. Now since they said the vowels are together, now what are the total numbers of vowels? 1, 2, 3, 4. So that's 4 factorial for the vowels. Over, do we have any numbers that occurs more than 1? Yes, we have. Do we have any letters that occurs more than 1? Yes, that's A. A occurred twice. That will now be over 2 factorial. Multiply by, you now count these 1, 2, 3, 4, 5, 6, 7. So these are 7. But you are going to take this as 1 because they said they occur together. So that's 7 plus 1, making it to be what? To be 8. So these 7 letters here, we assume this as 1, making it to be 8. So that's 8 factorial. So multiply by 8 factorial all over. Do you have any numbers that occur twice here? That's M and T. So that's over 2 factorial multiplied by 2 factorial, because M occur twice and T also occur twice. So that's 2 factorials, 2 factorials. So that's why we have 4 factorial over 2 factorial. So let us press it. We have 4 factorial over 2 factorial. Then multiply by 8 factorial over 2 factorial multiply by 2 factorial. The answer is 120,960. So these are the ways. Another question says, how many ways can the letter in the word permutation be arranged? Permutation be arranged of the vowels are all together. Now, if you are talking about the permutation like this, now permutation is how many letter? Permutation is how many letter? Permutation contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. So that's 11 factorial. But they said all the vowels are together. So let us bring all the vowels together. We have E here. We have U. We have A. We have I. We have O. These are the vowels. Now after we remove the vowels, what remains is P. We have R. We have M. We have T. We still have T. We have N. These are the consonants. Now you don't forget that we'll firstly do the side of the vowels, which is 1, 2, 3, 4, 5. So that's 5 factorial. Then if assuming we have the one that occurs more than once, then we now say over that factorial of the letter. But we don't have, they are just ones. So now multiply by the other side here will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is 6. So we now make this to be 1. All the vowels to be 1. That's 6 plus 1. That's 7. That has to be 7 factorial. All over. Do we have anyone more than once? Yes. T here. T occurs more than once. So that's over 2 factorial. So the answer will now be, so we have it to be 5 factorial multiplied by, we have 7 factorial over 2 factorial. So the answer is 302400. So these are the what? The numbers of ways at which it can be what? It can be arranged. Next one says, how many teams of 4 can be produced? How many teams of 4 can be produced from a pool of 12 engineers? Now I told you, whenever you are talking about human being, just use the combination. Yes, just use combination. But yeah, don't forget, they said the team of 4. Yes, if you belong to this, you already belong to this. So the other is not concerned here. So that means you already belong. So that's it. So we want to form a team of 4 out of 12. So you already belong to this. Yes, you cannot say, because if it is permutation, if I as a person starts, if I as a person starts, yes, if it is permutation, I can as well start in the next one but change the next person. You understand? But yeah, if it is combination rules, if you are forming 4 people, if I say David, Goliath, Joel, and John, and I say Joel, John, Goliath, David, they are the same team. So assuming it is permutation, and permutation that will be 2, but combination will now be what? It's the same, like David, Goliath, Joel, John, and at the same time Joel, John, Goliath, David. It's the same thing. The same set of people in the A is the same thing in what? In B. So that's why. So, and are you telling me that if you form a team in your this thing, in your society, you form a team of, let me say, David, Goliath, Joel, John, that's a team. Another person tell you that what's the name of what are those in this thing? I say Joel, John, David, Goliath. You are saying the same thing. The only thing you did is that you changed the arrangement of the words of the name. The arrangement of the name is only the thing that is changed, but does not change the people that are in the words, that are in the team. But here we are talking about the words, the people in the team. So they say we should form 4 people. So that does not change the people that are in the team. So that's why it is combination. Now be 12, the total number of people, then combination 4 that we want to form. So let us see. So this will be 12, sorry, 12, then combination 4. So we now have the answer to be 495 teams of 4 that can be formed. 495 team of 4 that can be formed. Now, another question. Another question says that how many ways, how many ways can can the letters in the word daughter, in the word daughter, so DAUGHTER, be arranged in which the vowels do not occur together, in which the vowels do not occur together. Now, so unlike the previous one that we did, you understand, this one, the vowels occur together, but here it does not occur. Here it does not occur together, but here it occurs together. Now, what are even the vowels that we have? The vowels are from the daughter here. We have A, we have U, we have E. Then we have the remaining values to be D, we have G, we have H, we have T, we have R. Now, what are the? You will not do it like this, unlike this one, we did the factorial for the vowels, then multiply by this one and made this to be 1. But this time around, they are not together. So you take it as what? As 1, like each, not like the same thing. So they are not all together, but the vowels are not together. They did not occur together. So that means they occurs once. So what you're now going to have is like we should switch it like the previous one. So what is this? The factorial 1, 2, 3, 4, 5. So this one is 5 factorial, then multiply by. Then we have this will be 5 factorial, then multiply by. If you don't take this as 1, that will be 1, 2, 3, 4, 5. No, it will be, we have 3 letters. So now the numbers, the daughter here, the D, G, H, T, R, the consonant is 5 factorial. The numbers at which you can arrange them is 5 factorial. We don't have any numbers that occur twice. So that's why we have them to be 5 factorial. Assuming we have numbers that will now be over something. But we only have each of the letters appear once. Now multiply by the one of the vowels here. Vowels here, we have 3 letters. But numbers at which we can arrange them is 6. That means we can put them in the gap here. 1, 2, 3, 4, 5, 6. It's in between. So numbers at which you can arrange them is 6. Like we have 6 permutation 3. That's three vowels. We have 3 vowels, but we can put them. The arrangement of this can be what? It can be 6. Let me say the 6 spaces. In 6 spaces, we have 6 spaces. Yes, the total number of spaces we can have is 6 for the vowels. So, and we only have what? We only have 3 letters. three letters AU. That's why we have it to be 6 permutation 3. So we now press this on the calculator. 5 multiplied by 6 permutation 3. So that's 14400. So this is numbers of what? Of ways at which this letter can be what? Can be arranged. So we check it very well. It's very it is obvious that it can be what? It can be solved like that. So we check the daughter here. We can have a space here. 1, 2, 3, 4, 5, 6. So we can have 6 space in between the words, in between this consonant. Vowel can start first, it can end. So that means we can have what? 1, 2, 3, 4, 5, 6. So out of the 6, we have, how many consonants do we have? We have 3. So that's why it is 6 permutation 3. And let's get to 2 last questions and we end this section for today. And section is, the question is, find the number of permutation of the word history, taking 3 letters at a time. Now, this one is like they said we should find numbers of permutation. We should take 3 letters at a time. That means we have 3 letters. 1, 2, 3. We need 3 letters at a time. We have to take 3 letters at a time. Numbers of permutation. This one, since the history we have, history, it is, how many letters is that? That's 7. We have 7 letters. So we now need to take 3 letters at a time. So this should just be permutation. So that will be the total numbers we have, the total numbers of letters we have, which is 7. Then permutation, the 3 letters we are to take at a time. So if we now press this, we have 7 permutation 3. That's 2 10 ways. 2 10 ways. The reason is because this one, the reason is because it's only contained each letter. Like we have one single letter, like I appear, H appear once, I appear once, S appear once, T appear once, O appear once, R appear once, and Y appear once. Let's have another one. It says, how many 3-letter words can be made? How many 3-letter words can be made from the letter in success? How many 3-letter words can be made from the letter in the word success? Now this one, where we are now, it deals with cases. Now these 2 last questions that we solve deals with cases. Now they said 3 letters. So we have 1, 2, 3. Now, and the success we have here contain 7 letters. 7 letters. 1, 2, 3, 4, 5, 6, 7. It contains 7 letters. We have 3 S. We have 2 C. We have U and E. They appear once. Now the first case is this. So we now want to put 3 3 here. Now the first case, case 1, is what we know as the single case. Like we deal with these ones, each of them that appear once. And if you check very well, we have to put, and those ones that appear once, we have S can appear once, C can also appear, U and E. So these are the 4. And that's why the first case here will be 4 permutation 3. That is, we want to put, we have 4 elements that can be put here, but we only need 3 letters. So that's why out of the 4 letters, we need 3. That's why it is 4 permutation 3. So 4 permutation 3, the answer is 24. So we have this to be 24. That's the first case. Then case 2. Case 2 is for only one double, that is, only one double. Or let me say only double. And if you check very well, S, we can see double from S. So S, we can see double from it. We can see double from C as well. But we cannot see from U because U only appear once and E also appear once. Only one double. But now, if you remove, let's say you have S here, you have C. You have S, you have C. Now, if we remove from this S now, if I want to use S and when I want to use C, let me even use C. Or let me use S. Let me use S. You know, S, we can see double from it. We can see double from what? From C as well. Now, if you remove C, you know, if you remove S rather, it remains C. It remains C, U, and what? And E elements. Now, that shows that if we put S here, it will remain this space here. So, for this space here, we can either put C, U, or what? Or E. And if it is C, C as well, if it is C, C as well, then the space can either be S, U, and what? And E. Because these two contain the what? The double. Now the answer will now be, now I want to use C now because C is here. So it will now be, the C we have, you know, the space we have here is 3. Just 3. So that will now be 3 permutation 2 because we are talking about double. So 3, the space that we need is 3. Or, yeah, 3 permutation what? Permutation 2 because we are talking about double. So all over 2 factorial because it is double. So multiply by 3 permutation 1. So because, you know, the first one we talk about the double, that's why it is 3 permutation 2. And this one as well, 3 permutation 1 because it is just only one space. So because it is only one space, that's why it is 3 permutation 1. And this one, it should be 3 permutation 2 because it is what? This one is double space. So we don't forget the first one that we are talking about. I'm just only talking about this S or C. So assuming you have C or S, now assuming you are using S now, if it is SS, so this SS now, S is double, so it's already contain what? It's already occupied the 2 space. So, and out of how many space? Out of 3 space. So out of 3 space, it contains 2 space. So all over, because we are talking about double, that's why it is 2 factorial. Multiply by the third line. Out of 3 space, the third space contain what? 1. It will contain 1 letter. So that's why out of 3, it has 1. So this one alone is for S. And how many double do we have? We have 2 double. That's why you have to multiply by 2. So let us press this on the calculator. Now, so when we press this, press the bracket of fraction button 3 permutation 2 over 2 factorial multiply by 3 permutation 1 multiply by 2. We have this to be 18. Now the third case, case 3, we'll have the triple 1 and we only have one triple 1, that's S. And you know we are dealing with 3 letters, so the triple 1 S will fill the space. It will fill the space like that. So that means it's only appear once. So this one is 1. So the summation will now be the first value, that's 24 plus 18 plus 1, which means you now have it to be 24 plus 18 plus 1. So the answer is 43. So this is 43. And last question. So the total numbers of ways at which 3 letters word can be made from this word is what? Is 24 ways. So 24 ways. Now let's see. The last one says, how many 4-letter words can be formed from the letters in the word mathematics? Now case 1. Case 1 is for the single one as well. So don't forget 4 letters words. 4 letters. And this mathematics contain 11 letters. We have 2M, we have 2A, we have 2T. And we have the single one to be H-E-T, H-E-I-T-H. I, we have C, we have S. These are the single one. We have these two occur twice. So for the single one, so each of these will belong to the single one. So we have M once, A, T, H, E, I, C, S. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. That'll be 8 permutation. So you know we need how many letters? 4. So that's 4. So that's, we now have it to be 8 permutation 4, which makes it to be 1680. So you firstly do each of the letters single. Each of the letters single. Then the case 2 is we take one double only, no, like the previous one as well. And those one that occurs in double is MAT, that occurred twice. And don't forget the same way I did for this one, when I did one double here, when I use S only, I multiply by 2 because there are 2 here. So if I want to multiply here, it will be multiplied by 3. So let me do for M only. So for M only here, you have to fill what? 4th space. So that will now be into bracket of, this one is 3 permutation 2 because the space here is what? Is 3. So this one will now be 4 permutation 2. So the double needs to be spaced. Let me say if you have M here, you have M here. Now that means the total number of space we have here is 4. So 4 permutation 2 because we are talking about double. So because it is double, you have over 2 factorial. So multiply by. Now, what are the remaining values that remain? We have the remaining values to be, if you remove M from the total numbers of letters we have, if you remove M, it will remain A, it will remain T, it will remain H, E, I, C, S. So, and what's the numbers that remain? That's 1, 2, 3, 4, 5, 6, 7. Now, out of the 7, we need how many space to be filled? That's 2. So that's the meaning. So here is that this one is, out of the 4 space we have here, we need 2 to be filled by what? By the double letter here. All over, because it's double letter, we have 2 factorial. But out of the remaining numbers is what? Is 7. Out of the 7, we need them to fill what? To fill the 2 space. So that's it. To fill the 2 space. So that's why we have 7 permutation 2. Then this one alone, this one inside the bracket is only for 1 letter. And how many letters undergo the double? That's 3. So that's why we have to multiply by 3. And we have it to be into the bracket of, press the fraction button, 4 permutation 2 over 2 factorial, then multiply by 7 permutation 2, then multiply by 3. The answer is 756. Don't forget, that's the same way we did under this previous question. Now case 3. Case 3 here, this one will not take triple. But because we don't have triple one here, we only have double. So the only thing we can still say is that let's take 2 doubles. So if you take 2 double, so 2 double, like you have M and A, we have M and T, we have A and T. So these are the 2 doubles. M and A, M and T, then A and T. These are the 2 doubles, that is 2 letters that are the same. And 2 that are what? That are this. We have the 2 letters that are what? That are the same. And other 2 that are what? That are also the same. 2 letters that are the same, and other 2 that are what? That are the same. So like MM, AA, AATT, you understand? But in this case, we have it to be, in this case too, we have it to be 2 letters that are what? That are repeatable. That are the same. 2 letters that are the same. That's just the case 2. Now, the same thing applicable to this. Don't forget, we fill the space for this case 2 here. For this case 2 here, we fill the space here. No, this one is talking about 3 space. So when we did for S alone, we have it to be in how many space? We are looking for 3. Then we are looking for 3 space, 3 letters. then we are able two doubles here, two doubles. So that's why it is 3 permutation 2. Since it is double, so that's why we have it to be over 2 factorial. Then multiply by how many letters remain? That's 1, 2, 3. So since it is 3 letters that remain, then we need to put only 1 letter here. That's why it is 3 permutation 1. Now this is the last case. That's case 3. Now we say for the case 3, 2, 3, like we can have MA, we can have MT, we can have AT. This one is very simple. So we want to speak 4 space. Now case 3, don't forget you want to fill 4 space here. So we now have it to be. So you can either use, since it is 4 space we want to find, so you can either use 4 factorial over, don't forget that it is, you can have AA. That's 2 double. So we can have it to be 2 factorial multiplied by 2 factorial. And don't forget how many letters contain that. That's 3 letters. So that's why we now have it to be what? Multiplied by 3. If you press it on the calculator, you are going to get 18. Or you use, don't forget we have 4 space, then permutation 2. All over, since it is double, we have it to be 2 factorial. So then multiply by what? Multiply by 3. If you use this, you are still going to have it to be 18 as well. So at the end of everything, we have to sum the answers together. That is 1680 plus 756 plus 18. Then when we sum it together, we have 1680 plus 756 plus 18. The answer is 2454 ways. So that's it. That's the answer. You can go over and over and over again. Now this is the way to solve this. So thank you very much. I remain Ishola Blessing, popularly known as General David. So follow us, like, comment, and subscribe for more videos on any aspect you want. Thank you very much. God bless you.